It's not possible to walk across a room. And here's why. Let's say this is you at point A, and you want to walk over here to point B to eat a healthy bowl of fruit. To describe this motion, you could say, starting at point A, you move half the distance to point B. Then, from there, you move half the distance to point B again, and again, and again, until you reach point B. The problem is, you can always divide the distance from you to point B in half. In order to reach point B, you would have to repeat this process infinitely. And it isn't possible to do an infinite amount of things in a finite amount of time. This issue is known as Zeno's paradox, and there's a problem with this logic. We know it's possible to walk across a room. If we couldn't, how would we know what fruit tastes like? I encourage you to pause the video and try to think of what's wrong with this reasoning. While it's true it's not possible to do an infinite amount of things in a finite amount of time, it is possible to move a finite distance in a finite amount of time. For our journey to be possible, we would have to prove that the distance from point A to B is finite. It would be helpful to define our position as a function of how many half distances we've moved. For simplicity, I'll refer to these half distances as strides. So, for example, our first stride would put us at 1/2 the distance from point A. The next stride would put us at 1/2 plus 1/4 the distance from point A. The third would be 1/2 plus 1/4 plus 1/8. And the fourth would be 1/2 plus 1/4 plus 1/8 plus 1/16. You might see a pattern here. We can represent our position from A as 1/2 to the n number of strides plus all the previous strides. This is called a series, which is a set of numbers defined by a function that are all added together. We can also rewrite these additions using sigma notation to make it look nicer. Here, the sigma represents addition. The bottom number shows where we start counting from, in this case 1, and the top number represents where we stop counting. Notice here the stop value changes, which indicates how many strides we've taken. We want to know what this sum approaches as n approaches infinity. But just by slapping a limit on the front, it isn't really obvious what the limit of the sum will be. To make it easier, let's rearrange some of these values. We'll start by adding up all of the sums. Now, you might be able to see a pattern. Do you see it? We can say this sum equals 2 to the n minus 1 all over 2 to the n. We can then break this fraction apart into 2 to the n over 2 to the n minus 1/2 to the n. This can simplify to 1, and we get 1 minus 1/2 to the n. Now we can see the limit of 1 as n approaches infinity is 1, since it has no relation to n. And the limit of 1/2 to the n as n approaches infinity is 0. Therefore, the distance between point A and B is 1, which is a finite distance. Now, if you travel over a fixed period of time, you'll be able to reach your destination, and you can finally eat that delicious bowl of fruit.